Hi everyone, hope all is well. In this video, I want to do a quick demonstration of how easy it is to actually extract drinking water from ocean water and be left with two byproducts. One is of course the drinking water and the other product will be the salt. Now I've done a previous video in regards to this. It was using an air still to complete the process. It completed the process in around about 11 hours. This is going to take considerably longer, except we won't be using any electricity to do it at all. In fact, all we'll be using is these two jars. So I have one large jar, one smaller jar. The smaller jar needs to be able to fit inside the larger jar, like such. And then we also need to be able to put the lid on top as well. So make sure that the jar on the inside here is no bigger than the outside of this one here. Otherwise you won't be able to put the lid on. Now, once you've worked out exactly which jars you wish to use, the next thing you're going to need, of course, is your ocean water, which I still have some left over from the previous experiment I did using the air still to process it. This time I'm going to measure out about a litre of water, I believe, into that jar, and then from that we'll see exactly what we can extract using nothing but the power of the sun. So you're looking at 250 mils here. Want to repeat this process 4 times. Get ourselves a litre in that jar, and from that, once I set the timer, we'll see exactly how many days it takes to actually extract all the water from the seawater. See, 1 litre of water fits nicely inside this jar here. Now, one of the great things about this larger jar is the fact that it has a conical lid in it. So when we put the lid on, it actually has a conical shape to it at the top here, which means any of the moisture that is evaporating out of this centre jar will actually run down the sides of this larger jar and will accumulate around the bottom of it. So you can see when I put this jar inside as such, that, and then to complete it, it's just a matter of putting the lid on top like such. Another good thing about this jar here as well is it has this rubber seal on it, so it's going to stop any evaporation outside of the jar itself, and basically it will retain all of the moisture inside it. So it works very simply. As the sun shines through it, it's going to heat the water up in that center jar. It's going to evaporate it. It's going to run and accumulate up the top here. The cool air, so the air blowing past the outside of this jar here, is going to make this fog up. Like, obviously it's not going to fog up straight away, but I'm guessing by tomorrow lunchtime this will be fogged up and you'll start to see moisture running down the sides of the jar. The idea is eventually it should accumulate around the bottom here of this. We should be able to lift that jar out of the center, and then we should be able to tip all the moisture out of the bigger jar into a cup, and we should have hopefully 950 ml of water is what I'm guessing. I know in the last experiment I did lose a bit because I was a bit late getting to the still at one stage, and there was a little bit of overflow. But with this one here, I'm hoping to retain all of the moisture actually in the larger jar. There shouldn't be any loss whatsoever. One of the things that you've got to keep in mind is not to spill it while you're moving it around. So I've actually set mine up exactly where I want it, so I don't have to move it. And now it's just a matter of waiting. And what I'll do is over the next few days, I'll just keep taking video footage of the still as it completes the procedure. And then hopefully within a week, maybe 2 weeks, who knows, depending on how much energy the sun's putting out, we should have some drinking water in here, and we should have salt in that center jar. And while I remember it, there's a couple of reasons I've decided to go this direction with this solar still. I did have an elaborate plan drawn up. It was a tabletop setup where I actually had 2 containers, one inside the other, and everything was on a bit of a lean. It was all plastic as well, which meant that, you know, you're keeping plastic tub out in the sun. Over time, plastic in the sun wears down and actually degrades and breaks and falls to pieces. I actually went into the supermarket hoping to get the you know, a couple of the plastic tubs, and I seen these there, and I'm like, that's perfect. Obviously glass is made of silicon, it doesn't degrade in the sun, so it doesn't matter how much sun's energy gets put into it, it's not going to degrade, and it's not actually going to pollute the water that we're trying to collect in the bottom here. Because remember, the water in that center jar is ocean water, and of course you can't drink ocean water. So the whole idea of this is to actually extract drinking water from the actual ocean water that's in the center jar. And by doing it this method, we're keeping it as clean and tidy as possible. Plus, we've also got the durability of the jars as well. So this is something that, providing you look after it, should last forever, in theory. Now this is 1 hour and 10 minutes into the experiment, and you can see already that moisture is condensing on the sides. So it happens pretty quick. Of course, there's absolutely no moisture in the bottom of it just yet, but that's a positive sign. Well, it's time for an update on the solar still. So this is day 2. We're about 48 hours actually into the experiment itself. As you can see here, there is quite a bit of condensation on the inside of the jar, of the large jar. Still plenty of water in the center jar as well. But we had some sunny periods throughout the day today. So it's given it a good opportunity to get some heat into the jar, which is resulting in the water evaporating out of the center jar. The evaporation, so the air inside here is rich in moisture, and then you get a cool breeze like that's blowing now, blows past the edge of the jar, which forces the air inside, or allows the air inside to cool enough for the liquid to condensate against the outer edge of the jar. And that results in it running down the edges and into the bottom here. And as you can see on the bottom, we're getting quite a bit of water there now, which is a bonus. You're looking at possibly between 50 and 100 mil there at least, I'd say. So it just shows that the actual process is working really well. How long it will take to actually remove all that water, I guess only time will tell. But I'll keep you all updated. Now, to make things interesting, I wanted to make a bit of a prediction about when I believe that center jar will be completely empty, or as close to as possible. I believe that within 20 to 24 days that it should be completely emptied, providing conditions remain the same. Obviously between then and now, conditions may start to cool off a bit, which will slow the evaporation process down. But then again, we may start to get a few sunny days in between then and now. Lately it has been a little bit overcast, as you can see, which results in the process being a little bit slower than it normally would be in really sunny conditions. So I guess the best thing we can do is just keep updating. But I believe 20 to 24 days, so you're talking another 22 days to complete the process. So this is 1 week, 1 day into the experiment. As you can see, the jar in the center is slowly getting reduced, and the external jar, the large jar, is definitely getting more fluid in it, as you can see from that there. So the experiment is definitely working, it's just incredibly slow. Alright, now we are currently 2 weeks into the experiment, so I've allowed there to be at least 14 complete cycles, that is 14 days of everything being warm, evaporating more what I can out of the center jar here, and then 14 evenings where it has gotten cool enough to actually recondense the liquid into the bottom of the jar. Now, I was going to continue until the experiment was completely completed, but unfortunately I'm a bit pressed for time with it. So at this stage, what I would like to do is to see if I can actually improve it, improve the results. So what I'm going to do is I'm going to actually empty this out, measure exactly what I have over the entire period that I've done it for the last 2 weeks, to see exactly what quantity of water I've extracted from the center jar. That will give us an idea of the time frame that's involved in it to actually complete the entire process, and that will give me a base to actually work off in regards to seeing if I can improve the outcome. The way I'm going to improve the outcome is I'm hoping to actually get another jar, if possible, that has a tap on it, and then I can drain it out daily. So I'm not re-evaporating the material that's in the bottom of the bigger jar as well. We're only concentrating all the energy on evaporating in the center jar. At this stage, each cycle that passes results in water evaporating from the center jar as well as the outside jar. Hopefully by eliminating the water that's in the outside jar, so the drinkable water, the fresh water, more energy can be put into actually evaporating the center jar. That's the idea anyway, and I guess the only way to find out is to give it a go. So at this stage, the best thing I can do is remove the center jar and measure this liquid up. This is the first time I've opened the lid. I haven't wanted to open it since I started the experiment, purely because there is moisture content in the air that's there, and once I open it, it will escape, which distorts the results of the experiment somewhat. But I've decided to do it first thing in the morning, so of day 14, and that way it hasn't had time to actually heat up and have a moisture-laden atmosphere. Take this off. Remove the center jar. That's the center jar that actually has seawater in it. You can actually see on the bottom there's a fair bit of sediment developing on the bottom, so it is starting to concentrate the salt that is actually in the water. And then from this here, this is our liquid that we've collected so far. And there is quite a bit there. It's nothing spectacular, especially for 14 days, but it is still worth measuring it to see what the results are. That way I can get a daily rate. Even taste it just to see whether there has been any salt accidentally spilt during the experiment. Try and get everything I can out of here. No smell to it or anything like that, it just smells like clean water. So at this stage here we have a little over 150 mil. So it's 150 mil of potable water from the 1 litres that we started with at this stage. So now that we have that, we can actually sit that aside, and I'll bottle that up, and then we can add it to the completed experiment at the end, the completed quantity at the end. Just a matter of resetting it. This jar back in the center, the seawater. So, pop the lid back on, and there you have it. And just like that, we've turned ocean water into drinking water. Okay, now we've come to the moment that everyone's been waiting for, and that is simply to do a taste test on the water. Now, from everything I've done in the past, this water should just taste like distilled water, which I have tasted before in a previous video. What I'm going to do is I'm using a 1/4 cup measuring spoon, and I'm just going to remove 1/4 of a cup out of here. That way I can keep the track of exactly what I've consumed and what remains of the water as well at the same time. So it's just a matter of tipping it in, of course. There's exactly 1/2 a cup in here, so 1/4 of a cup's probably a bit extreme, but we'll give it a crack anyway. And this water tastes a bit different than the previous one. It's not bad, but it is different than the previous distilled water I've had. And I'm not entirely sure what the reason for that is. Whether there was just a little bit of the salt water that bounced out of the center jar perhaps at some stage, but it doesn't taste bad by any means. In fact, I'd be more than happy to consume that. What I've found quite interesting is it's actually, you know, taken me the 14 days to get 1/2 a cup out of that. But if done correctly and on a large enough scale, we should be able to work out exactly how much we can produce per day from this unit here. So I did the maths, and from the 150 ml of water over the period of 14 days, it works out to be about 11 ml a day from this setup here alone, which is not a fantastic amount of water, but I'm sure if I did a little bit more maths, I could actually sort out exactly how many of these setups I'd need to produce the 3 litres of water I'd need to survive each day. Now, of course, humans use a lot more water than 3 litres of water a day themselves. I've become very conscious of how I use water myself. I know just by washing up the dishes and stuff like that, it's amazing to see exactly how much water we do waste, how much water actually goes back down the drain. Now, of course, no water is really ever wasted. If it goes down the drain, it's running back out into the river systems or back out into the ocean eventually anyway. Either way, it's getting evaporated and coming back as rain at some point. Now, there's obviously plenty of water in the ocean, so that evaporation process will not cease. It's going to continue forever. So the fear that we're going to run out of water is not entirely correct. I don't believe we'll ever run out of water. I believe we may become incapacitated. So basically, we're going to use more water than what's being generated by the environment, and I think that's one of the biggest concerns at the moment. And one of the ways to alleviate that is to stop wasting so much water to begin with. So that pretty much wraps this video up. I know it's taken 14 days to get to this point here, but there you have it. Basically, after 14 days, we got ourselves 150 ml of water. It works out to be about 11 ml a day. Keep in mind that that center jar is only 1 litre. So out of that 1 litre, we're producing about 11 ml of water each day. From that, you should be able to calculate exactly how many days it's going to take to produce 3 litres, or better yet, how many of these units you would need to have to produce 3 litres of water a day. In fact, I might do some quick maths in a moment and I'll be able to work that out. Okay, so I've had the opportunity to go over the figures. From the 11 ml of water that's produced each day from the solar still, I believe it will take about 272 of these setups to produce 3 litres of water each day. Now that's a phenomenal amount of equipment. You're talking 272 jars, and then 272 smaller jars as well. It would be an absolute massive setup. Another way to look at it is if it's producing 11 ml a day, it's going to take 272 days to produce 3 litres of water. Now, by the time, if you're desperate and you needed to produce that 3 litres of water, 272 days is a bit of a stretch. There's no doubt about it. But what that shows us is it is possible. The process works, there's no doubt about it. It's how nature does it. It's how it's done in this solar still. So there's no doubt about the process being functional. It certainly is. The biggest issue is trying to speed it up. So the next video in this series itself, I'll be aiming to try and improve the rate at which the evaporation and condensation process happens. Now, as you can see in this video here, I have gone ahead and I've removed that fluid to see if I can increase the speed of it just by removing the produced liquid each day. So that's the drinking water. I remove it from the jar each day and then reset the trap. Basically, it's like a solar cell trap. So we reset it after removing the drinkable water from it each day, which will mean that the only fluid that's been evaporated in the jar itself is actually the salt jar itself, so the salt water jar itself. And by doing that, hopefully we can find some improved results in the experiment itself. But other than that, that's absolutely everything for this video here. I look forward to seeing you in the next video. Don't forget to give it a thumbs up and give it a like if you enjoyed this video. If you found it helpful, please don't hesitate to put any comments in the comment bar as well. I'm more than happy to communicate with anyone who puts some comments in there as well. We do get quite a few inquiries on other videos and that as well, and I'm always quick to answer as quickly as possible. Thank you, cheers.